Okay, hope everybody's doing all right today. You'll notice something a little different. I'm going to record during your class today because remember the assembly that's tomorrow during third period. So third period's lesson and test, I had to switch those. So I wanted to go ahead and get that out of the way, just make sure. Which is really sad because Kiva was saying that she wanted to be recorded the other day, and the one day I'm recording second period, she's gone. So, all right, everybody say hi, Kiva. Wow, that was really enthusiastic. Okay. But, anyways, a couple things. Don't forget your test is tomorrow. Parametrics and hyperbolas. That's coming up. How many people have been getting ready for that? A few hands, okay. You still got one more night. You got tomorrow morning. If you have any last minute questions, I'll be here. Door opens 7:45. Beyond that, we have a couple things to talk about on Monday and Tuesday as far as polar equations go. Next Wednesday will be the day that I'm going to go ahead and provide you to let you just go ahead and look at the review, work together if you haven't already had the opportunity to do that. And I also want to go ahead and let you know what your semester average is going into the final. So really, from this class's perspective, I mean, there's only 1 week of school left. You test next Thursday for your final. This is the last full Thursday we have of the year, so things are going to be happening pretty quick, okay? In fact, who are my seniors? Okay, so you guys will test on Tuesday. Remember, Tuesday is the even numbered periods, so probably I'll just have you guys out in the hallway. You'll take your exam. But I did want to go ahead and show you something. There is just one typo that I found. If you look at number 1, answer C, 2 square root of 5 over 2 should be negative as well. Okay, so if you want to go ahead and make that change, that's the only typo I found. Okay, so it's really not as important to everybody else, but to the seniors who are going to be testing very quickly, yes, that's going to be important to you guys. So on number 1, answer C, the second part should be negative 2 square root of 5 over 2. Okay, should just have a negative on there. All right. And there's not a whole lot more to talk about, unless anybody just has any questions about anything coming up. Today we're going to talk about how to convert polar coordinates to rectangular and back again, and that's it. Okay, so let's see what we have here. We want to go from polar to rectangular first, because that's definitely the easier of the two. So if you have a polar coordinate with the radius and your theta measure, whether it's in degrees or radians, in order to find the rectangular, you just want to use these two formulas right here. X equals r cosine theta and y equals r sine theta. Oh, sorry. And you might even recognize those. That was how we first identified a point on the unit circle. And you remember there's your diagram moving horizontally and vertically. It's been something that we haven't talked about for a long time. But really, it is just a series of formulas. Okay. So let's go ahead and do this. We're also going to have the opportunity to spiral in some material where we used to evaluate degree and radian measures on the unit circle. You remember our happy minutes? Of course, those were happy memories. Okay, so let me show you what I mean. Let's go ahead and get right to it. So for these first ones, we definitely will not need a calculator. In fact, we're not going to make the decimal values. But the only one we're going to need a decimal value for on this page is E. But we'll get there in a minute. So let's say I have point P, which has a radius of 4 and a radian measure of pi over 6. So what quadrant would this point lie in? 1, 2, 3, or 4. Okay, so Chris is saying 1. He's absolutely right. So all I'm going to do is plug my information into the formula here. So I'm going to go ahead and say x is equal to the radius 4 times the cosine of pi over 6. And then y would be, again, the radius 4 times sine of pi over 6. Converting a polar to rectangular is so much easier than going the other direction. And I'm not saying going from a rectangular to polar is difficult, it's just that it involves a little more. Okay, definitely a little more work. So let's go ahead and do this. We said quadrant 1, so I'm going to draw a terminal side here. I'm going to connect it to my x-axis with a perpendicular segment, creating a right triangle. So what is pi over 6 in degrees? That's 30. So here's 30. So this would be 60. So remember, on the unit circle, the radius is always 1. Don't worry about what the problem says. When you're evaluating the trig functions, go back to what we did on the unit circle. Okay. Does anybody remember what was the side length across from 30? Been a while since we've seen these. It is 1/2. Remember, the smallest side, or shortest side, I should say, is always half of the hypotenuse. Does anybody remember what's across from 60? Is that okay? I'm sorry. Square root of 3 over 2. Yes, that's absolutely right. And we're in quadrant 1, so they're both positive. And remember, even if you didn't remember that, you could remember the general characteristics. The shorter side is always x. The longer leg is x squared root of 3, and then the hypotenuse is 2x. Okay. So let's see. What is the cosine of 30 degrees, or pi over 6? What was cosine's ratio? It was what over what? Okay. It was started with an A. Adjacent over hypotenuse. So this would be 4 times the square root of 3 over 2. And what would that give me? 2 square roots of 3. There would be the x value. So what is sine of 30 degrees, or pi over 6? 1/2. It was opposite over hypotenuse. So 4 times 1/2 is 2. So see, those are the values I'm going to use in my ordered pair. So the rectangular version should be 2 square root of 3. Oops. Sorry. 2 square root of 3, 2. There you go. So if I were to take the grid of a Cartesian coordinate system, just a normal grid you're accustomed to working with, if I were to take a polar coordinate grid and place them right on top of each other where the origin and the pole met, both of these points would be at the exact same location. Okay? And that's it. That's how you go from a polar to a rectangular. Questions? Okay. Well, let's try another one. Let's try B. Okay. So here we go. Point Q, the polar coordinate is -2, 135 degrees. Can anybody tell me what quadrant this point should be in? Ooh, we're close. Y4. There you go. Now, the 135 will absolutely be found in quadrant 2, but if the radius is negative, remember, we find that length in the exact opposite direction. So this point has got to be somewhere in quadrant 4. So I'm going to go ahead and make my quadrant 4 a little bit. Actually, no, I'm going to know why I did that. I still need to work with quadrant 2. Okay, so let me go ahead and do this. I'm going to set up my formulas. X equals the radius, -2, times the cosine of 135. And then y equals, again, -2 times the sine of 135. Okay. But again, we don't need to use the calculator because we recognize 135 as one of our original 16 values on the unit circle. Now, Brianna did say it was quadrant 2, so I'm going to go ahead and draw this here. This would be 135 degrees. So I'm going to connect it to my x-axis, just like I've always done. What's the reference angle? This guy right here. What is it? It is 45. So this is a 45, 45, 90 triangle. Okay, so again, the hypotenuse is 1, the radius. Anybody remember the side lengths of this triangle? Brianna? Square root of 2 over 2. That's exactly right. Remember, this was the only isosceles right triangle we had. Now, there's something I'm missing. And what quadrant are we in? Oh, well, now the point is in quadrant 4, but 135 degrees is in quadrant 2, so I need to make sure that horizontal x is negative. Okay. So even though the point, we know it's in quadrant 4, go ahead and create the triangle based on the measure you're given, because it's going to work out. Let me show you what I mean. This is going to be -2 times, well, what's the cosine of 135? So use this 45-degree reference angle. So remember, cosine is x over r. So x over r, so it's -square root of 2 over 2, right? So the negatives cancel, the 2's cancel. So what do I have? 2? Square root of 2. There we go. Okay. And then let's do the same thing for sine of 135. So I have the negative 2, but what's sine of 135? Remember, that would be y over r, opposite over hypotenuse, so it's just square root of 2 over 2. So what will this give me for the y value? Negative square root of 2. So I've got my x and I've got my y, so I know the point in the fourth quadrant, square root of 2, negative square root of 2. And see, does it make sense that it worked with our signs? For a rectangular point, if it's in the fourth quadrant, x would have to be positive and y would have to be negative. And see, that's exactly what we ended up with. Okay. So there you go. This point right here would show the exact same location on a polar grid for negative 2, 135 degrees. Okay. Is anybody having trouble or not seeing how I'm going from a polar to a rectangular? Okay. So let's go ahead and try one of these. Just try one more. Okay. There we go. Let me get rid of this. Delete that. Let's go ahead and try this last one. Now, this last one, we are not going to be able to create a triangle because 7 pi over 18 is not a value that we recognize. Can anybody tell me, or at least make your best guess, what quadrant would this point end up in? 1, 2, 3, or 4? Okay, 1, no. 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 2, there we go. It would end up in quadrant 2. Now, to kind of help you see that, why don't we convert this radian measure to degrees? How do I do that? Negative 7 pi over 18. What would I multiply it by? 180 over pi. There you go. If you want the degree measure, you multiply by 180 over pi. If you wanted the radian measure, you multiplied by pi over 180. Okay, so let's see. The pi's cancel. 18 and 180, the common factor is 18. In fact, how many times will 18 go into 180? 10. So this is actually negative 70. Okay. So if I were to start rotating, negative 70 would probably look something like this. But wait a minute. Why did I say quadrant 2 and not 4? The radius is negative, so I'd find that distance in the opposite direction. Okay. So this point is going to go in quadrant 2. So we can already guess what should the signs of my rectangular point be. How do I go from the origin to a point in the second quadrant? X would have to be negative. Y would have to be positive. So I should be ending up with something with a negative and a positive. Okay. Well, remember, it's just a formula. So to find x, I'm going to take the radius times the cosine, and I'll just go ahead and plug in negative 70 because my calculator's in degrees. So let's see here. We're going to end up with a negative, but is that what's going to happen here? Because it looks like I have 2 negatives. You remember, we actually mentioned this the other day. Cosine is what type of function? Starts with the E. He's even, so cosine of negative 70 is equivalent to cosine of 70. All right. So if I were to go ahead and plug this into the calculator, negative 13 cosine of negative 70. See, I do end up with a negative. So let's say negative 4.45. Okay. So negative 4.45. So looking good so far because we got a negative answer. So now let's use the formula to find y, which would be the radius, negative 13, times the sine of negative 70. Now I need this one to be positive. Is that what's going to happen? Yeah, because sine is odd, so sine of negative 70 is what? What would that be equivalent to? What can I do with that negative? Okay. Well, you can take the negative and pull it to the front. So the two negatives are going to cancel. Remember, an odd function like sine of negative 70 would be negative sine of 70. In fact, let me go ahead and catch up. Negative 13 sine of negative 70. So I should end up with a positive 12.22. 12.22. So that should be my coordinate. Negative 4.45, 12.22 should be the same location as that polar location. There we go. Any questions? Anybody having a hard time? Okay. Like I said, I'm just wanting to spend a little more time on the other side. So, you've got C and D. Those are going to be worked out the same way. Those are actually values that you're familiar with off the unit circle. So I'd encourage you to try those without a calculator. You can create a triangle. The answers are online, or you can ask me about them. Okay. But let's talk about how to go in the other direction. What if I have a rectangular, but I want to go ahead and write that as a polar? Okay. The reason this just takes a little longer is because when you're describing a location in a Cartesian coordinate plane, there's only one way to do it, one way to get a location. But as we've seen throughout this week so far, if I want to write the coordinate of a polar location, how many ways can I represent that? There were 4 different ways I could write the same location, and that's what we're going to be finding. Okay. Well, here's what we do. If I've got a rectangular coordinate, finding the radius is very simple. You simply take the square root of x squared plus y squared. That's just based on the Pythagorean theorem. Okay, and you can see that in the diagram. Now, depending on if x is positive or negative, for all of them, you're going to have to take the tangent inverse of y over x. Okay. But if x is negative, you'll have to add pi, or you'll have to add 180, depending on if you're in radians or degrees. Okay, and I'll kind of explain in just a minute why that is. There's one quick question I want to ask you, though. Think all the way back to inverses. It's been a while since we did these. What 2 quadrants, Natalie, will tangent inverse be restricted to? One and 4. Perfect. Let's just see how much we remember. Max, what 2 quadrants would sine inverse be restricted to? Not 2. It is 2 of them, but which 2? And it does not include 2. That's what Natalie said. 1 and 4. There we go. And William, finish it up for me. What about cosine inverse? What 2 quadrants will he be restricted to? 1 and 2. That is right. 1 and 2. Very good. Okay. All right, so let's go ahead and take a look at an example. So I've got the point S, 1, and then negative square root of 3. So what quadrant is this in? Positive x, negative y. That'd be in quadrant 4. Okay. So first thing I want to do, see, this is my x, this is my y. In order to find the radius, I'm going to take the square root of x squared plus y squared. Okay. So that's actually the square root of what? Okay, 1 plus 3, square root of 4, so my radius is 2. But see, as I said earlier, it's not that this is more difficult, it's just that there's more points to find. So because I know my radius is 2, I'm going to have 2 coordinates where it's 2, and then I'm also going to have 2 coordinates where it's negative 2. All I need to do now is figure out what are the corresponding measures that go with those. Okay. So now we're looking up here. Is x positive or negative? X is positive. Okay, so I'm going to be using this and this only. All I need is tangent inverse of y over x. So let's see here. Tangent inverse of, well, negative square root of 3 divided by 1 is just negative square root of 3. Okay. What quadrant is this going to put me in? Because we just said it's restricted to 1 and 4. Would it be 1 or 4? Which one? Okay. I heard 1, I heard 4. Okay. Think about it. Where is tangent negative? Is tangent negative in 1 or 4? 4. Okay. Because if it's in quadrant 1, both x and y are positive, right? Okay. So let's see what that is. Tangent inverse of the negative square root of 3. Okay. So I'm going to come on over here. Let me get rid of all that. So tangent inverse, okay, escape, of the negative square root of 3. Oop, kick me out of there. So I'm getting a negative 60. Okay. So if I come on over here to my grid, okay, this is negative 60. Okay. Well, remember, where was our rectangular point? It was in what quadrant? It was in quadrant 4, right? So it would have to be somewhere on that terminal side. So right away, because it's the same quadrant as I have my tangent inverse, I already know that one of these has to be, what? Negative 60. But remember, you're finding coterminal angles. So now I need the other one that goes all the way around. So what's the counterclockwise revolution? That'd be 300. So I know 300. Okay. Now this is something that I like to go ahead and do. I mean, the formula has you go ahead and add, or excuse me, it doesn't have you do that. But think about it like this. Whether you have to add 180 or pi or not, wherever you end up with your terminal side, I like to go ahead and draw that through the other quadrant, just straight across. I make a straight line because think, the radius now needs to be negative, right? So if I did have a negative 2, it would take that point and put it right back over here. But it kind of helps me to visualize what's happening because now I need this angle and I need this angle because that's going to help me with my other 2 points. Does that make sense for everybody? Okay. So you can use vertical angles to kind of do that. If this one right here is going to be 60, that's got to be 60 as well. So remember, the negative just tells you direction. Okay. So Kaylin, what's the positive for counterclockwise rotation that'll go with negative 2? 120. So this would have to be 120 degrees right here. Now, what's the other one that goes all the way around and is coterminal with it? Negative 240. And there you go. So like I said, it's not really more difficult. It's just that you got to find more points. Okay? Because a polar coordinate is not unique like a rectangular coordinate is. Okay. How are we doing? Okay. All right. Now that's the only one where it actually works out nicely. It was a value that we were accustomed to. The rest of these, we are going to have to use the calculator. We're going to have to use decimal values. Okay, so let's go through another one of these together. So B is negative 3, 6. Okay. So what quadrant would this point fall into? Negative 3, 6. It would be in 2. X is negative, Y is positive. Okay. The easy part is finding the what? The radius. Okay. What's the formula that I use again? I keep forgetting. Yeah, square root of x squared plus y squared. So the square root of negative 3 squared plus 6 squared. So I'm looking for 9 plus 36. Square root of 45. Now we're going to go ahead and take the decimal answer, but again, just to kind of review, because the school year's ending and I know you want to try and get in as much math as possible, what would it be if I were to simplify the radical? What would square root of 45 be equivalent to? 3 square roots of 5. Okay, good. Okay, but like I said, we're going to go ahead and get the decimal here. So you can type in, 3 square roots of 5 or square root of 45, whatever you prefer. So let's say 6.71. Okay. So because this was 6.71, I'm going to do just like I did a moment ago. I'm going to create all 4 of my coordinates. So I'm going to say 6.71, 6.71, negative 6.71, negative 6.71. That's a habit that I got into. I just went ahead and, basically set the foundation for what I'm about to do. Is everybody okay with why I do this? Does anybody have any questions? Okay. So now, how do I go ahead and find a value of theta that's going to help me find the others? There you go. Now, here, because x is less than 0, we are going to have to go ahead and add 180 degrees. But I don't like to go ahead and do that in the calculator. I kind of just go ahead and use the visual here. So let me show you what I mean. Let's go ahead and take tangent inverse of, well, what is y divided by x? 6 divided by negative 3, negative 2. Okay. And then if you want to go ahead and actually just use the formula straight out, okay, you can definitely go ahead and add the 180. But just think about tangent inverse. What quadrant would that put me in? 1 or 4? What do you think? Would this put me in quadrant 1 or 4? Why 4? Because it's negative. It's negative 2. Okay, so let's actually see what that is. So I'm going to go ahead and say tangent inverse of negative 2. So it gave me, let's say, a negative 63.43. Okay. So I'm going to go ahead and draw this right here. Let's say this is negative 63.43, right? But what quadrant is my rectangular point in? We said it was in quadrant what? Quadrant 2. See, that's why you have to add the 180 to get over to that quadrant. Because what's the measure of a straight line? 180 degrees. Okay. So like I said, I don't really worry about using the formula. I just kind of use the visual here. Because if that angle is 63.43, that means that this angle is 63.43 as well. Okay. So what I need is this angle, and I need this angle. So what's the counterclockwise angle if I started here and went over? How would I find that? What could I do with the 63.43? I can subtract it from 180. Okay. Now, because it's already negative in my calculator, I'm going to go ahead and say 180 plus, because the negative will subtract it. Okay. So I'm getting 116.57. 116.57. So that's one of them. 116.57. Okay. Well, how can I find from here the counterclockwise going around? There you go. So I need to take 180 plus. Now, I know my answer is going to be negative, so I'm going to go ahead and do this. I'm going to say negative 180 plus, and when I add it to the other negative, it's just going to go ahead and combine them and give me a larger negative. So I've got negative 243.44. Okay. So negative 243.44, okay, degrees. Now I'm going to go ahead and turn my attention over here. I know that the point negative 3,6 has got to be somewhere in the second quadrant. But remember, with a negative radius, I'm actually looking for some point here that's actually going to go back in the opposite direction. So now I need this angle, and I need that angle. Well, don't we already have one of them? Which one do I already have? Yeah. So I know another point has to be negative 6.71, negative 63.43. But how am I going to find this other one that rotates all the way around? Subtract that from 360. Now again, you can just go ahead and type it in. I'm going to go ahead and say 360 plus, and then I'm going to go ahead and plug in, if this will let me. There we go. because it's already negative, so it'll take care of the subtraction. So I'm getting 296.57. 296.57. There you go. Questions? Anybody having a hard time? Okay. I'll tell you what, let's go ahead and try one more, and then we'll be done for today. Okay? And I'll let you decide. Would you like to look at C or D? Okay? C is in quadrant 1, and D is in quadrant 3, so I heard a C. Let's do a vote. How many people want C? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And how many people, just so your voice is heard, want D? Okay. All right. So if you want to ask me a question about it, I mean, it's in the notes. But let's look at C. Okay. So point W, 710. Okay. So let's say that, W is going to be right here. Okay. And if it helps you to go ahead and do that. Okay. Absolutely. Okay. So let me go ahead and give you a little bit of time to go ahead and take a look at that. I'll catch up to you in just a second. Now, again, I'm not going to give you an assignment over this. This is not on the test tomorrow. But if you've looked at the review, what do you notice? There are some problems like this. Okay? There are some problems. And some of your answers here will have a 0.99, and that's perfectly fine. Just because we said we're going to round to 2 decimal places. So let's at least make sure that everybody's on the same page. Okay. What's the first thing you should do if you want to go from rectangular to polar? Find the radius. Okay. So here the radius would be the square root of 7 squared plus 10 squared. And what are you getting for that? Square root of 149, which is 12.21, right? Okay. All right. So then I'm going to go ahead and create all 4 of my points. So 12.21, 12.21, negative 12.21, negative 12.21. There we go. Oh, actually, Jaylee, weren't you asking about that earlier? The restaurant? You still need to go? You sure? Okay. 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 How many people are still working on the problem? Okay. So I'll give you a little more time. Mm-hmm. Excuse me. Well, you may not be done, and that's okay. Well, let's go ahead. How would I go ahead and find the first value of theta that I can start to base everything off of? What's the trig function I got to use? Okay, so it's tangent inverse. Okay, so I'd go ahead and take tangent inverse of 10/7. Okay, now because x is positive, we don't have to worry about adding this on. Again, I'm going to go ahead and draw it straight across just to visually see which ones I need. But somebody help me out here. What is that to 2 decimal places? 55.01. There you go, 55.01 degrees. So because this point is in quadrant 1, I need this measure, but then I also need this measure going all the way around. Okay, so one of them was already given to me, 55.01. So I'm going to say 55.01. So if you go clockwise all the way around, that's when I ended up with negative 304.99. Okay, and then now I'm going to go ahead and extend it all the way across, because if it had a negative radius, then I would find that length in the opposite direction, right? But from standard position, I need this measure, and I need this measure right here. Okay. So if you were to go ahead and find those, I got a 235.01 for the counterclockwise, and then I got negative 124.99 for the clockwise on that one. Okay. And those should be the 4 coordinates that would be equivalent to 710. Okay. How many people were getting those points? Okay, good, good. Any questions? Anybody having a hard time? Okay. And remember, what's tomorrow? Test. Okay. So test. Okay, so make sure to look over your notes, hyperbolas, parametric equations. Okay. If you need anything, I'll be here 7:45 in the morning. Okay. All right. Is everybody done copying this? Can I go ahead and erase it? Oh, someone not. Oh, this kid. There you go, sir. All right, cool. All right, we are done for today. Okay. Oh, sorry, sir.